All right, so welcome to the first of these 5 video clips that talk about Divemaster theory. And this one will focus on physics. So one thing to remember, when you look in your instructor manual for the Divemaster course and you come to section 2 that deals with knowledge development, remember, if the candidates are using Divemaster e-learning, the theory development happens within the e-learning. So that will save you some time and effort as an instructor. However, you probably want to make sure that you are refreshed with your own theory, understanding, and knowledge, just in case your Divemaster candidates have questions. So here's how you can prepare for that. Remember, physics really begins with the open water diver course. So you've gone through all this training. So again, trust that you have that foundation there. At worst, you're looking at refreshing this information, but you have passed all the theory exams along the way. At some point, you learned it. So it's really just a matter of reminding yourself of that theory and getting comfortable with physics again. So to do that, look at the tools that are available to you. And again, trust that system. And if you use them, if you take the time to refresh and review that content, this will become easy like everything else is as well. So physics, like I mentioned, starts in open water. So if you go to your e-learning product, you as an instructor, you'll have all these e-learning products now as a benefit of membership. So when you come to the open water diver course, the e-learning, you select it, you pick your language that you want, and then you've got your information here in being a diver, and being a diver 2 is where the primary physics knowledge is. And you'll recall that in the open water diver course, that's where you learned that basic foundational information regarding pressure-volume relationships and density. And there's a chart in there. So I would start there, look at open water, and then you also want to go to Divemaster e-learning, which you will have as well as an instructor if you're renewed. And once you enter that Divemaster e-learning, you want to go to the section that's called Dive Theory Review. And so here, all those physics topics are nicely divided up in sections. So if I want to look at the relationships of gas pressure, volume density, and temperature, I would come here. And again, this is the chart that started all the way back in open water. It doesn't change just because you're a dive master or an instructor. Physics stays the same. And this chart, the one that you learned in the open water diver course, is the one that you want to commit to memory and have your candidates commit to memory. Because if you can remember and draw at kind of on demand this chart, pretty much all the physics answers will come to light when you do that. So you've got your depth, and you pick your flavor, if it's metric or imperial, and then the pressure change. Again, it's a whole number with the depth changes in there. And then the air volume is simply a fraction of the pressure that you had at that depth. And the density is simply times whatever you had for the pressure. And you can even have a little drawing. So as I go through this video clip, you'll see me come back time and again to that chart. The other product that you want to also consider reviewing is Dive Theory Online. And this is not part of the Divemaster Crew Pack, but you can order it for your candidates. And this is something that you will have, again, as part of your renewal benefits. And so you can go into Dive Theory Online, and now you've got all the content in there as well that you can review. For again, dealing specifically with physics, we can come here, and that's where we're going to find some nice reminders on that and to help you with that. There's also, of course, the encyclopedia, and that has a wealth of information, but obviously the physics section is pretty robust, and again, nice drawings in there to explain it all, as well as the formulas that you might need for physics too, if you're a formulaic person. And encyclopedia exists as e-learning as well. There is one other piece of resource that maybe some of you might not be aware about. When I come to the PADI Pro site and you go to resources, training, and course-related documents, you're going to select Divemaster. for your course. And I'm going to select English today. And once that page opens up, under Other Resources, there is a document called Divemaster Presentation Notes. And this set of notes are speaker's notes from the previous version of the Divemaster course. And even though it's the previous version of the Divemaster course, the physics hasn't changed in the time that it took PADI to revise the Divemaster course. Physics has been around a very long time and is unlikely to change. So there's a dive theory review. So I'll show you how you can use this Divemaster Presentation Notes document to help you remind yourself how to teach physics, and also as a source for sample questions when you work with your candidates. So aside from prepping your own physics knowledge and physics awareness, as it were, you also want to remember that everyone learns in a different style. So from a physics point of view, typically someone's going to understand and use physics either in a visual sense, or if they're able to remember the formulas, then that's the way. So as an instructor, I want to kind of have an understanding of how both work so that I can help my Divemaster candidates understand and use the physics questions directly. So when it comes to the visual aspect, for that, we're going to refer back to the chart. As you saw when I showed you the open water physics section of the Divemaster, there is that chart that shows the pressure, volume, and density relationship. This is something that, as I mentioned, you want to commit to memory and practice drawing it out and have your candidates do the same thing. So that way, it's a quick visual reminder of everything that goes on in pressure-volume relationships. So what you want to do is draw the surface of the water. You can have a bottom of the ocean if you want to have that included in there. And then I've got a column for the depth, I've got a column for the pressure, and I've got a column for volume, and then finally density as well in there. And so that way, when I now I'm about to work on physics, I'm going to draw this chart, add the numbers in here to give me that visual reminder. So depth, we're going to start off with 10 meters, or for those of you that are imperial, I add my 33 feet. The next depth is going to be 20, and from imperial, it's 66. And then we have a 30 meters in there, which is going to be 99. And if I wanted to, I could add the next one down there as well. The pressure is going to be 1 at the surface, the atmospheric pressure. And when we go underwater, the biggest pressure change is that first 10 meters or 33 feet, where it doubles. So that's something you have to remember. But all you're going to do is remember to make that a 2. So you're going from 1 to 2. And then the next 10 meters, 33 feet is another pressure. So that becomes the 3. And then the next one gives you a 4. And once you have that pressure in there, that makes the volume and density really easy to remember. Because the volume, if you have that as 1 something liter, cubic foot, whatever it might be on the surface, when we go underwater, that volume is going to decrease, and it's going to decrease in proportion to the pressure. And that proportion is actually that number that you had in the pressure. So at 10 meters, 33 feet, it's going to be 1/2, or a half. And the next one then at 66 feet, 20 meters, it's going to be 1/3. And then the next one is 1/4. So a quarter of the size of that at the surface. When it comes to density, it's a similar expression using that pressure. So as we go down here, whatever we had at the surface, if we take that as a whole number of 1, if we squeeze all that into half the space, it means everything is twice as close together. So the density is 2, factor of 2. And then here at a third volume, everything is compressed by 3, and so on. So again, drawing this quickly whenever you're going to answer a physics question will help you in answering that question, because it's a visual reminder. And so by using the chart and remembering this drawing, that is something I use as a foundation when I'm answering my physics questions in a visual sense. The other way is to use formulas. So where do I find these formulas? Probably the easiest place is in Dive Theory Online. That's where you're going to find the cleanest presentation of the formulas. So I come here to the physics section, and it doesn't matter if you're in metric or imperial, it's the same set of topics once you're inside that presentation. And once I come to this topic 405, if I scroll down past the charts, you'll see one formula presented here, and then some sample problems. So this is where, for me as an instructor, I would equip myself with this formula, try and memorize it. It's not that difficult to remember. You have to remember 4 things. Write it down a few times so that it sticks in your mind. And so then, with that in mind, let's take a look at an example question. And for my example questions, I like to use the Divemaster course presentation notes. Because when we come to theory, and you'll see it in the other video clips too, I have presentation content that explains or that teaches someone to understand the theory. And then at the end of the topic, there are sample questions that you can give to your candidates, like here. So let me make that slightly bigger for everyone. Yeah. So here goes a little note. Use the following questions to test candidate understanding. So for me as an instructor, I don't have to come up with a question magically, right? I can use this as a resource. I can grab them from the Divemaster exams, and I just change the numbers to make something different in there. But these ones that come from the Divemaster presentation notes are nice because they are different than the Divemaster exam ones, and I don't need to do any work. I just grab them, and the candidates will not have seen them before. Remember, with questions, it's great to kind of test your candidate's understanding of the topic, but don't try and teach a theory topic by just throwing out hundreds of questions. That's not how someone learns it, right? You need to make sure they understand the basics, the foundation of the information before giving questions. And in physics specifically, that's where that chart comes in. So here's this question. It is a volume and depth question. If a diver takes 45 minutes to breathe half a cylinder of air at the surface, about how long will it take that diver to breathe the same amount of air at 20 meters or 66 feet, assuming all variables remain the same? And so now I'm going to answer this in 2 ways. I'm going to do a visual version of it using the chart as the foundation, and then I'm going to answer it using a formula. So let's take a look at how I would answer that question using it as a visual learner. So with that, I'm going to keep in mind the chart that we drew. And so we have something going on at the surface, and we have a diver that's going to go down to the bottom of the ocean. And we remember from the question that that depth was 20 meters or 66 feet. And so we had somebody breathing an amount of air that took them 45 minutes to breathe that at the surface. And the question is, how long is it going to take them to breathe that volume of air down underwater? Right? So I have my little drawing. I have the pressure. So I know I'm dealing with 3 atmospheres at that point. I have my density. I'm going to add in there as well. In there. And then finally, just a visual reminder of what the volume is as well. Okay. So in this question, when I look at this, that diver is going to go down here, and they're going to breathe that certain volume, which was half the tank, in 45 minutes. And the question is, how long will it take them to breathe that same volume, that half volume, at depth? And when I look at this, I can actually use both these areas, both the volume and the density, to answer the question. From a density point of view, we see that every breath is going to be 3 times as dense. So therefore, whatever it took me to breathe 45 minutes worth of gas at the surface, I'm going to breathe it 3 times faster underwater, which means it's only going to last 1/3 of that time. So which means my answer is going to be 15 in there. The other way to look at it is from a volume point of view. The question doesn't tell us the pressure of the tank and the pressure differences. It just says that it takes us a certain amount of time to breathe half the volume of the cylinder. So in that sense, that time is an expression of the volume. So we can say that we're breathing a volume of air that takes us 45 minutes to breathe, and then underwater, we're going to breathe the same amount of air in how much time? And that is going to be 1/3 of that time. So again, we come up with the same answer. And that's what's cool about doing the visual approach, is as I'm looking at this, I can realize that because I'm now underwater, I'm affected by the increased density, and there's also that volume relationship as well, and then I can use either one in there. Right? This question was a little bit confusing, perhaps initially because it doesn't mention the pressure, the PSI, which a lot of these questions will do. But again, if you think about what's going on, we have half the tank is being breathed at this depth, and so what are we breathing, or how long does it take us to breathe that same volume at a certain depth? Okay, so we just looked at a visual representation of how to answer that question. So then just look at a way to answer it with the formula. And remember, it's a pressure-volume relationship. As I mentioned earlier, there is the density approach you can take as well, but really it's an expression of volume, this 45 minutes that I'm breathing. So I'm going to remember my formula, which was P1 times V1 is going to be the same as P2 times V2. There, right? So now I'm going to put in the numbers that I know. I know the pressure at the beginning of this exercise. It takes 45 minutes to breathe half the volume at the surface, so the surface pressure is 1. And the volume was half the volume of the tank breathed in 45 minutes, so I'm going to put 45 as my expression of volume. It's not a volume sense in maybe the way you're used to looking at volume, but it's an expression of that volume because it took us that amount of time to breathe half the volume of the tank, and that half volume of tank underwater is what we're looking at. And underwater, we were doing that at 20 meters, 66 feet. So the pressure there is 3. And what we don't know is what the answer is going to be here. So rearranging this, I've got 1 times 45. That equals 45. Here, I need to get rid of this 3. So I'm going to divide by 3 to lose that. They come up and it comes over here. So 45 divided by 3 equals 15. Same as the visual representation, but for someone who's more happy remembering a formula, this can be one way of doing that. All right, so hopefully that helps show how I use the 2 different methods. Remember, if you go to Dive Theory online, you can see a similar type of question answered here. Let me find it. So the big chart, there we go. And so here I'm, in this case, taking a volume of 3 cubic feet down to depth. And what's my new volume? So this is an application of that formula. So again, so if you weren't sure yourself, if you again use these sample problems, hopefully it will help you get more comfortable with it. And then, as always, if you need further hints and tips or you're still struggling, don't hesitate to reach out to your regional training consultant or one of us in instructor development. Thank you very much.